Okay, so hello once again, dears. Now this is the last part, last topic natin for this week on bacterial identification through mga slide preparation or smear preparation. And for this activity, what we're going to talk about is the hanging drop method. And this is a test to determine motility or the movement or if bulihok ba ay mga kagaw, okay? And that's, again, for determination of bacterial motility. And motility is, again, achieved through the presence of your flagella or flagellum, which are, again, your organs of locomotion. And not only that, but through motility, your bacteria can, at least motility, pwede siyang go from one place to another. Hence, it can establish infection through different parts of the body and can also help them evade the immune system. Diba? So, muna siya mga important sa motility. Pwede siya maka-further sa infection, kaya maka-spread man siya from one area to another. And because maka-move away man siya from the cells of your immune system, pwede siya evade sa immune response of the body. Okay, so again, this is your hanging drop method, again, to determine bacterial motility. Okay, so first, again, start with bacterial motility. Bacterial motility, again, is achieved through the presence of your flagellum or flagella, if that can. And the main protein that composes your flagellum or flagella is your flagellate. And the Latin translation of flagellum is whip. Okay, whip. And watch me whip. Alright, so your dimension is about 15 to 20 micrometers long and 20 nanometers wide. Okay, so again, through the presence of flagella or flagellum, makalihok or motil in mukha organism. Now, we have general rules. Your cocci, as in all cocci, are non-motil. Okay, they don't have any flagella, so dili na sila mulihok. Okay, so they achieve the evasion of other body sites through mga different virulence factors, for example, mga hyaluronidase niya, mga enzymes, etc. So, but generally, cocci are non-motil. Once like flagella, so di sila mulihok. For bacilli, most of them are motil. Most na, dili tanan, because there are bacteria or bacilli na non-motil. Example, Flagella. That's a bacilli, but it's not motil. You have Acinetobacter, it's also non-motil. Ayan. Acinetobacter, non-motil. Also, Yersinia enterocolonitica. These example, so these example of bacilli, they are non-motil. So that is why most of our bacilli are non-motil. And for spiral organisms, your spirochetes, of course, they're all motil. Because of the mga spirochetes, you have BLT, diba? Si Ju katawa, I can. Remember siya ko ito, kitsa to siya. Okay, your BLT, Borrelia, Leptospira, and Treponema. Okay, so that's for the initial introduction to bacterial motility. Okay, so again, as you can see, mapag-gram positive or gram negative ba na siya, your flagellum or flagella are anchored on the cell membrane. Okay, this will make sure na strong yung kakapit. Okay, and in a way, this would help in the propelling or in the movement of your flagellum or flagella. Okay, so it's anchored on the cytoplasmic membrane. Mapag-gram positive or gram negative, magaling na. Alright, now for your different methods in determining bacterial motility, we have about 7. So you have your wet mount. This is your wet mount is your hanging drop. You have flagellar staining, diba? Sa atong staining techniques, you have stains for flagellum or flagella. So by the name itself, ang ginastain ra is flagella or flagellum. Inoculation of motility media, right? Your SIM, antibody-distance leader. Serologic tests, yeah, we use mga antibodies. Fluorescent antibody technique, swarming phenomenon, meaning makita na siya daan sa imuhang culture media plate. And you have dark field microscopy, again usually used for spirochetes. Okay, alright. Now we go now to your first method, which is your hanging drop method. Number 1, ang procedure natin is we use a molding clay, usually any clay or vaseline, para mugamatag ring, okay, na i-circle na mugamata. Mugamatag circle out of a clay. Next, mugamatag cover slip. And then, sa cover slip, on the center of the cover slip, using an inoculating loop, mukotag loop full from a broth na puno o bacteria na ay motility or motil. And then, ito na siyang i-drop sa cover slip at the center. Okay? Next, i-invert na ito ang slide. Okay? Invert the slide sa cover slip and then ibutang siya sa molding clay. Nari picture later para mas makasabot. And then again, in a way, since hanging drop siya, kano siya hanging drop because the culture or the drop of culture is suspended. Okay, and through this, makita natin ang motility sa organism. And dapat dili mo fall ang drop or dili siya mo touch at the bottom of the slide. Okay, mawala na ito ang organism, dili na siya makita. Okay? And first examine under LPO and adjust the light, and then to determine motility, HPO na tabuto. Wala na hindi na tayo what do you call this? OIO. Okay, alright. So this is the of the hanging drop network. As you can see, diri ang slide nato na examine. And then, una magabasa ng circle, di ba, na clay. Alright? And then, ang cover slip mo na nato at the center, a drop of, a loopful or a drop of culture from the broth na naay media, na naay motile organisms. And then, in a way, mag-hanging drop or suspend ang ibang organism. And muli siya itong examine under the microscope. Okay? Alright? So, in a nutshell, muna siya yung itsura. Alright? Okay, so, hopefully in the, sa lab animals mag-clarity siya. But I hope na get to the overall view sa ito ang setup. Okay, as you can see again, we have, so basically circle imuhang circle imuhang clay, right? And then patong ang cover slip ana. And then ilan sa cover slip na ana dito di ba? Clay ni siya. And then patungan mo ang cover slip, patong sa cover slip. And then ang ilalim atong cover slip na ana dito ang drop of the culture broth or broth na ay mga motile organisms. Okay? And that's what we'll examine under the microscope. Alright? So, then natin mo siya hanging drop natin. Hanging drop kay nakasuspend, nakahang ang inyong drop full of motile organisms. Okay? Alright. Now, for our next method of flagellar staining, we have two methods. You have Grace and Clark's. So, we'll differentiate the two. For bacterial suspension, ang gamitan sa Grace kay nutrient average na plus 2 to 3 ml of sterile water. Ang diri lang is distilled water lang, 3 ml, wala yung any sludge. And incubate pa ang Grace for 10 to 20 minutes. And ang Clark's kay na ay ang suspension na ma-create from the addition of 3 ml distilled water and 1 milliliter colony na ay faintly opalescent suspension. So medyo opalescent yung say na siya hindi siya na naka-clear na yung rag pag-blur kamay, opalescent. Okay? Alright. Next, for inoculation, sa Grace, ang gamitin natin is pipette. Drop lang ang suspension is deposited on one end of the slide. So, if kanyang slide, okay, so one end, i-deposit na ito siya nila. That's for Grace. For Clark's, using a loop, large loop full sa tunga. Okay? So, that's the difference na sa inoculation. Next, for smear prep, both of them are slide is tilted to allow the drop to run down the slide. So, basically, di ba, kato imuhang Grace o imuhang Clark center, both of them are silang duha yung i-tilt para mo-run ang drop all over the slide, di ba? Para matabunan ang tanang slide. Okay? And then imo siyang i-air dry, Grace in tilted position, and then ang imuhang Clark sky in a level position. So dili mo siya i-tilt. Okay? So Grace ni siya i-tilt, ang Clark sila level position. Okay? Alright. Now for staining, sa Grace, the mordant and stain are separated. Okay? So, a mordant 8 to 10 minutes and the stain for 5 minutes. For Clark's, kay combine na siya, mordant and stain. Okay? For reagents, same ang mordant, tannic acid. Ang stain lang mo differ. Sa Grace, kay Zeal's carbofuchsin, and for Clark's, basic fuchsin. By the way, same na siya po ng fuchsin. Alright? And the tannic acid serves as a mordant. Muswell ang flagella, therefore, ma-color siya sa inyong stain. Okay? And yeah, ma-precipitate causes the flagella as it coats and precipitates with the flagella. So as it precipitates, no, ay muswell man ang flagella, so therefore, ma-coat siya easily po sa inyong stain na either basic fuchsin or carbol fuchsin. Okay? Alright, so that's for the staining. Alright? Now, we go on to the different arrangement of your flagella. We use the suffix tricos, meaning hair, because your flagella appear like hair-like extensions. Okay? Alright, so we have, number one is atricos, meaning wala siya yung flagella. So atricos, therefore, wala siya yung flagella, meaning it's non-motile. So, muna siya yung mga Klebsiella, again, bacilli na non-motile, and Yersinia enteropolitica, Acantobacter, diba? Okay, so those are your atricos, meaning hindi sila motile, wala sila yung flagella. Okay. Next, we have what we call your monotrichos or polar flagella, meaning at one end lang siya na. So, a good example of organisms na monotrichos, you have Pseudomonas, and Vibrio, and Campylobacter. Okay? So, kung sila yung mga monotrichos, one flagellum lang at one end, or polar flagellum. Okay? Okay? Alright. Next, we have amphitricos on both sides. Research ko example. Ang example daw is alkaligenes faecalis. Okay? Alkaligenes faecalis, amphitricos, both ends. Amphi, both sides. Dito amphitheater na. Okay, amphi, both ends. Next, you have lophotricos, meaning tuft, okay, or like crest, meaning na ano siya in both ends. Or siya kumpol, yes, kumpol of flagella at one end, okay, or both ends, pwede po. So lophotricos, and we have your peritricos, meaning all around, peritricos. Most of the gram-negative bacilli, your enterics, E. coli, yes, my nana, those are peritricos. Most of your gram-negative bacilli are peritricos. Okay, so inana flagella all around. Okay, all right. Now, next we have this, another way to determine motility is we inoculate sa motility media. Now, this is again your sulfide indole motility medium or SIM. So, we inoculate again in a deep or butt, di ba? How do we inoculate? We stab all the way, mga 3/4. Okay, and if motile ang medium, a motile ang organism, what happens is, as you can see, we're blurring effect, na diffuse growth along the stab line. So as you can see, meaning, pag-stab mo di ba? So the organism is there, ni-move away siya from the stab line. That is why na diffuse growth, na murag pagka-blurred sa kilid. It means ni-swim away siya from the stab line. Muna siyang motile. Whereas kani, as you can see, diba, clear ang nasa kilid, murag wala rin nahitabo. Because again, it's not motile. Ni-grow lang ang kagaw or ni-grow yung organism along or on the stab line. Okay? So that's just a difference na siya ang sulfide indole motility. So usually sa lab, we don't perform, if mo determine ka if motile ang organism or not, dili na mo perform halong drop, makita na siya daan dali sa sulfide indole motility. So it saves time, dali na po kayo siya pag-interpret. Basta again, na diffuse growth, di ba, on the kilid of the stab line, that's motile. And if kani, wala growth sa kilid, then it's non-motile. Nagtubo na siya along the stab line. Okay? Because again, wala siya yung flagella. And kanina yung flagella, so pag stab mo, ni-swim away siya from the stab line. Muna siya na-growth sa kilid. Okay? Alright. So that's for SIM. Again, sulfide indole motility. By the name itself, tulo na ka-test. Diba? Sulfide production, indole production, and motility. So it's just, kaya siya one of the results na siya sa inyong SIM. Okay? Alright. Next, we go na to serologic tests. When you say serologic test again, we detect the antigen and the antibody. We use the antibody to detect the antigen. Because your kagaw, they have different antigens on their body. And what we use is the flagellar H, or what we detect is the flagellar H na antigen. Okay? This one, flagellar H antigen. Please take note, these are the different mga antigens. Usually, na-encounter na pa rin mga salmonella na testing natin sa serological. Again, capsular K, okay? Capsular K. Ngano mga K? Because K from German capsule, okay? Capsule. VI, virulence na siya, okay? Somatic O or onne, alright? And flagellar H or Houch, okay? And if masakitan ka pa, Houch, charot na. Okay, so flagellar H from German siya naman derive. Okay, so again, how do we detect this time is the flagellar H, the Houch antigen. Okay, and we use antibody. So since we use the H antigen, we use antibody, anti-H. Okay, so a positive reaction, if you mix mo ng anti-sila nimo and your kagaw, if may positive reaction, then it means na ang flagella or na ang presence of flagella. Okay, alright. Next, you go to your fluorescent antibody technique. We use again fluorescence microscope and we use an immunofluorescence stain for that. So, since again, immuno siya, we use antibodies and antigen pa rin. So, what we do is your fluorochrome dye, we add siya sa anti-H, diba? Which is your antibody, okay? Against the flagellar H antigen. Now, ato na siya i-combine, okay? And in the presence of the H antigen, pag add nila, so this reaction, because of this reaction, mo color ang dye, or mo emit siya of fluorescence. Okay, that is why na-anay color. So fluorescence indicates the presence of flagella. Because again, your anti-H reacted with the H antigen. Okay? So therefore, pag react nila, pagpasiga sa ibang fluorescence light, di ba, ma-excite ang naa sa fluorochrome, therefore, ma-release siya o light. Muna makitaan siya. But if wala yung H antigen, so wala yung bind sa anti-H. Wala yung reaction na mahitabo, therefore wala yung fluorescence na ma-produce. Okay, gets lang? Since na may H antigen, they react as anti-H, okay, which trigger the dye to emit fluorescence. That's why na-color. But in the absence of H antigen, wala may mo react sa anti-H, wala yung reaction na mahitabo, therefore, ang dye, dili po ma-excite, dili po siya mo-emit o fluorescence light. Okay? Alright. That's for fluorescent antibody technique. Next, we go on to swarming. I mentioned swarming, yes. So this is swarming, guys, because this is due to hypermotility, okay? Hypermotility of your organism. So as you can see, didn't yung inoculate na colony, and then i-swarm na siya. Because again, hypermotil. And a very good example of an organism that exhibits swarming is proteus. Ayan. Basta guys, ganyan, muingon ka na, what do you call this? Case studies. The organism exhibits swarming phenomenon, grab neck bacilli, press the buzzer. It could be proteus yun. Alright, and proteus species usually makakause siya UTI or mga urinary tract infections. Now, through the help of their swarming or hypermodal sila, muna makapropel sila from the bladder to the urethra, from the urethra to the bladder, and because again, it's hypermotil. Okay, so swarming phenomenon. So from one, diba? From one, hindi nila inoculate, swarm siya. Diba? Next is siya, flower, right? So because of again, hypermotil, you have flagella, I think proteus is still detritus pa rin. So again, hypermotil, proteus. Okay, swarming phenomenon. Alright. And of course, you have your dark field microscopy. Ayan, diba? Dark field microscopy, that's for your spirochetes. As you can see, diba? As I mentioned, sa characteristic motility sa inyong spirochetes, diba? It's spiral in motion, diba? Alright, so dark field. So as you can see, against the dark, makita mo ang mga spirochetes, diba? It's so amazing. Where's a word, right? But it's not a word. So spiral organism. Alright. Now, what do you want to say about spirochete motion? Now, your spirochetes, they have a special type of flagella known as your endoflagella. So they're only found in your spirochetes. They're known as your periplasmic flagella. Periplasmic meaning nagpalibot ang flagella all around its body. And then, one end of your flagella is anchored on the at one end of the cell. So anchored siya at one end of the cell, anchored siya at one end of the cell. So if move ni siya, move na tanan. Because again, both of them are anchored on one end of the cell. So kung sa movement niya from here, ma-influence niya ang other, meron siya kaya, pag, di ba, if mo siya ka mga spiral in motion, if you move ang one end, move mo ng one end, move sila together. Okay, so muna siya yung movement sa mga spirochetes because of their endoflagella or periplasmic flagella. Okay? Alright, okay. So again, we're known as your H-shell filaments. Okay, alright. So that's the end of hanging drop motility. Again, it's very short lang po, like very short lang. So again, it's a test to detect motility. Alright? But again, in routine lab, usually hindi na mag-hanging drop. Mu-opt na lang tao katong SIM because again, it's very easy to manipulate and very easy to interpret, and it saves time. Okay, right. So that's all for bacterial ID through smear prep and slide preparation, guys. Okay, so I'll see you on our next topic naman in bacteriology. Have a great day. Keep safe, guys, and wash your hands always. All right.